Okay. Yes, the hyperlink to decode and the small application of WeChat all is okay. All are okay. Okay, class begins. Let's continue to study the computer network technology. Last time, we have learned the basic about the computer network. So we will review some basic points. Then about the concept of computer network. Now, what is the computer network? What's the definition of computer network? What's the definition of the computer network? Computer network are connections of autonomous computers. So, computer network are the sets or connections of autonomous computers. So the computers should be independent to each other. Computers should be independent to each other. Independent to each other. They should be autonomous. Then computers are connected, including wired lines, including wired connection or wireless connection. If they can exchange information between each other. The two computers are said to be interconnected if they are able to exchange information. And the main purpose of computer network is to resource sharing or exchange information, communication, such as social communication or e-commerce, do many things for. So connection via a copper fiber, this is wired lines, and including wireless, such as microwave, infrared, or satellites. Nowadays, the internet is widely used. The internet includes many networks, all kinds of networks. They are connected. So internet is a network of networks. Computer network is different from distributed system. The distinction between a network and a distributed system lies with the software. Rather than with the hardware. This is a reason, right? Reason. For example, the key distinction is that a connection of independent computers appears to its users as a single coherent system. It has a single model or paradigm that it presents to its users. We need a middleware for distributed system, middleware, which is responsible for implementing this model, right? But in the computer network, this coherence model and software are absent. This is the distinction lies with software. We depend the network so much nowadays because computer networks are widely used in a variety of our life and industry. So computer networks have many uses, including business application, home application, and mobile users. right? In factory, computers are used to source sharing, usually with the model of client server. The goal is to make all programs, equipment, and especially data available to anyone on the network without regard to the physical location of the resource and the user. Usually we use client-server model. It is widely used and forms the basis of much network usage, right? Client-server means there is definitely a server running in somewhere in the internet, and client connects, replies to connect to the server, then get the service from the server, right? Home application. If I ask you why we need computer, why you have a computer or smartphone or a tablet, why we need network, you can answer. Okay, people usually bought computers for word processing. Well, for word processing and games, right? Usually, many years ago, we bought computers for word processing and games. Recently, the biggest reason to buy a home computer was probably for internet access. Now, many consumer electronic devices, such as set-top boxes, game consoles, and clock radios, comes with embedded computers and computer networks, especially wireless networks and home networks, broadly used for entertainment, including listening to, looking at, and creating music, photos, and videos, and share them with your friends, right? This is the social communication function of the network. Here lists some forms of e-commerce. E-commerce, for example, we can order books online. We usually buy books or any other things from the online shops. We can go shopping online. For mobile users, usually we depend on Wi-Fi, hotspots, and cellular phone system. They provide wireless connectivity, right? Wireless and mobile are related but different. What is the wireless? Wireless means the physical connection, physical media between the two parts. Is wireless. Means the physical media is wireless. The mobile means the movement of the user, supports the movement of the user, right? Wireless means the wireless physical media. And on the other hand, the mobile means the network supports the movement of the user, right? So they are related but different. So here it is combinations of wireless networks like mobile computing, right? Here we have desktop computers in office. Usually they are fixed, right? No wireless, no mobiles. But now in the offices, usually we depend on wireless and mobiles because we have smartphones, right? Smartphones or laptop, and they uses the wireless network, and we can move the smartphone, laptops, tablets to anywhere, any place, right? So it depends on the practical conditions. According to the covering area, depend on according to the size of the covering area, network can be classified into these kinds of networks. For example, PAN, LAN, MAN, WAN, and Internet. Personal area network, usually the smallest network, located in a very small area, 1 meter, usually in one body or in the area of a person. Local area network usually covers a room, building, or campus. Metropolitan area network usually covers a city, right? And the wide area network usually covers a country or continent. And the internet usually covers a country or continent, right? And the planet network, it is a new concept. In fact, the internet can be applied to establish a connection between the planets. For example, we can depend on satellite communication to realize the communication in the planet. So it is according to the scale, the size of the network, right? So here we explain the concepts of PAN, LAN, MAN, WAN, and the internet, right? Okay, we depend on the wireless network or Bluetooth. We usually use the wireless peripheral of a computer. Usually mouse, keyboard, the printer all depend on wireless network. It is very convenient for us. Local area network, we will illustrate the principles in the third chapter. We will explain the local area network in the third chapter. because it is very important types of networks. Local area network is a privately owned network that operates within and nearby a single building, like a home, office, or factory. Local area networks are widely used to connect personal computers and consumer electronics to let them share resources such as printers and exchange information. Metropolitan area network usually covers a city. It connects devices over a metropolitan area. Here illustrate an example of metropolitan area network based on cable TV or any other physical media. For example, fiber optics. WAN means wide area network spans a large geographical area, often a country or continent. And if an enterprise needs a security service in the internet, we can use VPN, that is virtual private network, built from virtual links that run on top of the internet. Okay. Internet works. Okay, we have explained the internet, a connection of interconnected networks is called internet works or internet. Here I uses the Lucas forms I, and these terms will be used in the generic sense in contrast to the worldwide internet. Here I is capital, uppercase I, capital I is a specific concept. Last class, we have illustrated the network protocol or network software. We have learned some basic concept of the network software, including protocol layers, the design issues for layers of the network, and two types of services provided by network, including connection-oriented and connectionless. This is some basic concept of the network. Although we use the networks every day, but if we study you will grasp the principle of the network. There are many things we should learn. For example, how to construct a network system. Network system includes very complex network hardware and software. So we should explain how to design a network system. That is the network architecture. How to design network hardware and network software. How to design the principles. It's a very complicated problem. So we should illustrate these things in in about 8 chapters. In 8 chapters includes physical, data link, network, transport, and application layers. While a network system is designed according to several layers, that is to reduce design complexity. Most networks are organized as a stack of layers or levels, each one built upon the one below it. Then the number of layers, the name of each layer, the contents of each layer, and the function of each layer should be designed very well, should be designed sophisticatedly for network, but they differ from network to network. The purpose of each layer is to offer certain services to the higher layers while sharing those layers from the details of how the offered services are actually implemented. That is why we designed the network system using layering, right? Protocol layering can make the underlying system transparent to the upper one, right? So when layer N on one machine carries on a conversation with layer N on another machine, the rules and conventions used in this conversation are connectively known as the layer M protocol. So we have a protocol in each layer. We have protocols in each layer. Here, layer N carries a conversation with the peer of layer N on another machine. What is the rules? What is the rules or agreement of their conversation? That is the function of the layer M protocol. So layer M protocol is used to make the conversation between the two peer layer M entity. So basically, a protocol is an agreement between the communicating parties on how communication is to proceed. Protocol layering or hierarchies, right, is the main structuring method used to divide up network functionality. Because the communication between two machines is very complex. We cannot depend a single software to realize the function of the communication between the two machines. We should use the structure method, divide up network functionality into several parts. Each protocol instance talks virtually to its users. Each layer communicates only by using the one below. Each layer communicates only by using the one below. That means, for example, layer 5 uses the service of layer 4 through the interface of layer 4 uses the service of layer 4 to realize the conversation between layer 5. Right? That means layer 5 uses the service of layer 4 to realize the communication between the layer 4 of the other machine, of the another machine. That means each layer communicates only by using the one below. Only use the service of layer 4, not layer 3, 2, and 1. And layer 4 uses the service of layer 3 to realize the communication between layer 4 of the peer entity in another machine. And at the bottom, that means the physical media messages are carried actually by the media. So this very like a large building with four layers. Layer 1, layer 2, 3, 4, 5. In this figure, we can see the location. We can see the points of layers, protocols, and interfaces. What's the function of layer? What's the function of protocols? Protocols is here, right? And the interfaces is here. Interfaces. Immediately neighbors. Between immediately neighbors, we have interface, right? Have interfaces. We know no data are directly transferred from layer N on one machine to layer N on another machine. No data are directly transferred from layer N on one machine to layer N on another machine. Why no data? Here, although we have a protocol, we denote a protocol here, but the lines, dashed lines. So that means the physical signal, the actual data is not transferred from layer 5 to another layer 5. The data is actually transferred from layer 5 to layer 4, then to layer 3, then to layer 2, then to layer 1, then transmission in physical medium, then to the next end, right? So no data are directly transferred from layer N on one machine to layer N on another machine. But how can we realize the communication between two machines? Because if layer 5 and layer 5 in another machine need to communicate with each other, but the data delivered from the up to down in the sending end. Then the data from down to up. So the layer 5 get the data from the source machine. So although no data are directly transferred, we can realize the data transmitted from the source to destination. Each layer passes data and control information to layer immediately below it, until the lowest layer is reached. What is the lowest layer? The lowest layer is layer 1, not physical media, right? So if a network system has 5 layers, then the lowest layer is layer 1. So until the lowest layer is reached, below layer 1 is the physical media. So layer 1 and the physical media are very different, right? It is not the same thing. It's not the same things. So below layer 1 is physical media, through which actual communication occurs. So we need actual physical media. We need physical media. If we have no physical media, we cannot exchange at all. We cannot exchange information at all. Okay. So physical media. Here we say physical media. We know it includes wired and or wireless, right? Wired or wireless, all okay. Both okay. But we need one physical media, right? Because the actual communication, the actual electromagnetic signal is transmitted through the physical media. So between each pair of adjacent layers is an interface. Between each pair of adjacent layers is an interface. So here we know where is an interface. We have interfaces between each pair of adjacent layers. Layer 5 and layer 4, layer 4 and layer 3, layer 3 and layer 2, and layer 2 and layer 1, right? Then we need also physical interface between layer 1 and the physical media. For example, we need Ethernet interface, right? We have Ethernet interface in your smartphone or your computer. We have antenna of smartphones and laptops. In addition to minimizing the amount of information that must be passed between layers, clear-cut interfaces also make it simpler to replace one layer with a completely different protocols or implement. So we need clear-cut interfaces, make it simpler to replace one layer with a completely different protocols or implementation. Why? Because the software, the technique of the communication and the networks are rapidly, right? Usually we need update the software, update the techniques of the network and communication. So we should update some protocol software or replace some hardware. So if we designed according to according to a formal protocol layering, and we use clear-cut interfaces, then it is very simple to replace one layer. Even the other layers above and below it without noticing, right? Without noticing, without layers above and below it even noticing. That means we can replace one layer with a completely different protocols or implementation with no effect to other layers. That is why we design a network system with layering, with hierarchy designs. So we called network architecture. So what is the concept of a network architecture? What is the concept? What is the concept of network architecture? That architecture means a set of layers and protocols of a network system. The specific of an architecture must contain enough information to allow an implementer to write the program or build the hardware for each layer so that it will correctly obey the appropriate protocol. So why we need an architecture, a network architecture specification? Because the specification of an architecture make sure that implementers to write the program or build the hardware for each layer correctly obey the appropriate protocol. So without an appropriate protocol, probably we cannot realize the communication. So we need protocol, and all parties obey the same protocol. So we need the specification of an architecture. Okay, let's have a rest for 10 minutes. Okay. Please keep connection. Please keep connection. Keep connection. We will continue after 10 minutes. Okay. Okay, let's continue. Just now, we have learned the concept of network architecture. Network architecture gives us the specification of how to design a network system. Contains enough information to allow implementer or networking programmer, networking application programmer, or a network implementer to write the program or build the hardware for each layer so that it will correctly obey the appropriate protocol. That is why we need network architecture. Now, what is the protocol stack? Protocol stack means the protocols, several protocols are linked layer by layer. A list of the protocol used by a certain system. One protocol per layer. And the network system has several layers. One per layer. So a list of the protocol is called protocol stack. So this figure is used to illustrate the principle of protocol hierarchy, right? For example, layer 1 is a philosopher. Layer 2 is a translator. Layer 1 is a secretary. Secretary means type words and send out. So this example is a very interesting architecture. For example, it says that we have there are two philosophers, one of whom speaks Urdu and English language, and one of whom speaks Chinese and French. So they have no common language, right? One speaks Urdu and English, and one speaks Chinese and French. So they have no common language. They need a translator. So each of them engage a translator. So translator works at layer 2, each of whom in turn contacts a secretary. Secretary works in layer 1. Do you understand? Right, so two philosophers have no common language. They engaged a translator. They each engaged a translator. So two translators. And each of whom the translators contacts their secretary. So we have this model. A philosopher at location A, another philosopher is at location B, right? They have no common language. So without translators, these two philosophers cannot exchange ideas. They cannot exchange ideas without a translator because they have no common language. So how to realize their communication? So if philosopher A has a translator A, philosopher B has a translator B, then the philosopher A can talk to their translator A, then translator. So how about the translator? The translators, translator A and B, right, have agreed on a neutral language. What is the neutral language? That means these two translators should use a common language, to exchange. You agreed on a neutral language known to both of them. For example, Dutch. So the message is converted to like this words. So the choice of the language is the layer 2 protocol, and is up to layer 2 peer processes. The translator then gives the message to a secretary for transmission. So, for example, by email or other methods, right? So, from this figure, we understood the principle of protocol layering, right? Well, usually, which layer is advanced? Which layer is the most advanced? We think is the layer 3, right? Philosopher, because the idea produced by the philosopher. The translator only implements the idea into a neutral language, right? The translator only knows the language, but the philosopher knows the idea. So the philosopher A produces an idea, and the translator translates the idea into a neutral language. Then translator is more advanced than, is higher than secretary. Why? Because the secretary only type the words, then use the network to send out. The secretary probably understand the idea and the foreign language. The secretary only know how to type the text, how to send and receive the message, right? So we have these two layers, layer 1, layer 2, layer 3. Okay, do you understand? It's very interesting. But this 3-layer system helps the two philosophers to exchange ideas. Example information flow supporting virtual communication in layer 5 So there are 5. We have explained last class. This figure illustrates how a large message is divided into 2 small messages, M1, M2. Then M1, M2 is assembled into a original message to the upper layer. So the receiver machine receives the original message sent by the source machine. It's some complex. We will explain this mechanism, this processing in detail in the later chapters. So we will not explain it in detail here. Design issues for the layers. Each layer solves a particular problem. Each layer solves a particular problem, but mostly include mechanisms to address a set of recurring design issues. These recurring design issues means some issues should be dealt with in several layers, not a single layers. For example, reliability. The codes for error detection or correction. Routing around the failures. That is, it is about reliability. Network growth and evolution. So we need some good addressing and naming mechanisms, or protocol layering method. The third issue is allocation of resources like bandwidth or any other things. The location of resources for multiple access or congestion controlling. Then the last one is about security against various threats. Security against threats. For example, confidentiality, authentication of communicating parties. The point is that there are some issues that are not wholly responsibility of any one layer, and they crop up again and again in the text. For example, reliability is often considered a key function. So reliability is a key function of the transport layer. Yet, reliability transmission mechanisms also appear in other layers. For example, in the data link layer for error detection or error correction using error queues, right? And routing around the failures in the network and replication at application layer. All of these implements reliability for us. So reliability, we need a reliability service So several layers should deal with these kind of issues. Codes in data link layer, routing network layer, and transport congestion control or retransmission in data link layer and transportation layer, right? So crop up again and again in the text. Layers can offer two different types of service. So two types of service, that is a typical problem in network system, because in history, we have two kinds of network. One is telecommunication network for phone. Telecommunication network for telephone. That is a telephone system. The other one is computer network based on packet switching techniques. So they are very different systems, very different network systems. One is based on one is based on connection oriented. The other is based on connectionness. These two kinds of network provides very different services to users. So in the computer network, two kinds of services can be provided by the computer network. So we here point out connection-oriented and connectionness services, also provided by computer network. Connection-oriented service is modeled after the telephone system. To talk to someone, you should pick up the phone, dial a number, talk, then hang up. That means we should first establish a connection, uses the connection, and then release the connection. That is the typical characteristic of this kind of network. In most cases, the order is preserved so that the bits arrive in order they were sent. In some cases, when a connection is established, the sender, receiver, and the subnet conduct a negotiation about the parameters to be used. What's the negotiation about the parameters, such as maximum message size, quantity of service required, and other issues? These are all parameters of the service. The other kind of service is connectionness. It is modeled after the postal system. Each message carries the full destination address, and each one is routed through the intermediate nodes inside the system, independent of all the subsequent messages. There are different names for messages in different contexts. For example, packet is a message at the network layer, and the frame is a message at the data link layer. But when the intermediate nodes receive a message before sending it to the next node, it's called store and forward switching. So what is the store and forward switching? For store and forward switching is the fundamental of the computer network. Because based on the store and forward switching technique, we used intermediate nodes received a message in full, then sending it on to the next node. That means store. What is the store? Store means the immediate intermediate node receive a message in full. Received means store. And forward means then send this message to the next node, hop by hop, right? Hop by hop. So the message will be delivered to the destination finally. Alternative in which the onward version of a message at a node starts before it is completely received by node is called cut-through switching. Cut-through switching is an optimized processing for store and forward switching. Normally, when two messages are sent to the same destination, the first one sent will be the first one to arrive. However, it is possible that the first one sent can be delayed. So the second one arrives the first. So the order of the messages probably cannot be kept. This is about the reliability. 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 Connectionless service cannot guarantee the quality of service, including the bandwidth, latency, or the order. So we say connectionless service provide an unreliable service. Here we say unreliable connectionless service. It's often called datagram service. Datagrams service. In analog with telegram service, which also does not return an acknowledgement to the sender. Here we listed 6 different types of service. For example, for connection-oriented service, we have reliable message stream, reliable byte stream, unreliable connection. They have different examples, application. For connectionless service, we have unreliable datagram service acknowledge the datagram, the request reply service. What is the acknowledged datagram? Acknowledge means the receiver should send back, should feed back to the source. The receiver should send a reply to the sender. That means acknowledgement. What is the service primitives? A service is formally specified by a set of primitives or operation interfaces. We tell the service to perform some action or report on an action taken by a peer entity. If the protocol stack is located in the operating system, as it often is, the primitives are normally system calls. This calls a trap to kernel mode, which then turns control of the machine over to the operating system, send the necessary packets. Here we list some typical primitives such as listen, connect, accept, receive, send, disconnect, etc. This is a minimum example of the service primitives that might provide a reliable byte stream. This figure illustrates a simple client-server interaction using acknowledged datagrams. Using these primitives, connect request, accept response, right? And request for data and get a reply, the disconnect. What's the relationship of services to protocols? Services and protocols are distinct concepts. In the last section, we have explained what's the location of the service and the protocols, the layers, right? Service means the lower layer provide services to the upper one. And protocols means the agreement between a pair of peer entity. So this is the distinction of service and protocols, the distinct concept. Now, a service is a set of primitives that a layer provides to the layer above it. The service defines what options the layer is prepared to perform on behalf of its users, but it says nothing at all about how these operations are implemented. A service relates to an interface between two layers, with the low layer being the service provider and the upper layer being the service user. This is the service concept. How about the concept of a protocol? A protocol, in contrast, is a set of rules or agreement governing the format and the meaning of the packets or messages that are exchanged by the peer entity within a layer. The format is very important, right? We need to use the standard format name to attend the online class, because based on the standard format of your ID and name format, we can simply recognize who have attended the online class, who haven't attended the online class. So we need a specific format. And for networking, we also need a format and the meaning of the packets or messages that are exchanged by the peer entities within a layer. Entities use protocols to implement their service definitions. They are free to change their protocols at will, provided they do not change the service visible to their users. This way, the service and the protocol are completely decoupled. Decoupled is a very well-defined mechanism. This is a key concept that any network designer should understand well. The service and the protocol are completely decoupled. They are distinct concepts, but they have relationship between each other. Service means the lower layer provides communication function for the upper layer. The protocol means a set of rules governing the format and the meaning of the packets or messages, meaning of the packets or messages that are exchanged by the peer entity within a layer. So layer, we have a certain protocol in the certain layer, right? Service means a layer n provide service to layer n plus 1. That means that is here. For example, this is layer n plus 1. This is layer n. This is layer n minus 1. So layer is layer n plus 1, layer n minus 1. So service means layer n provide service to layer n plus 1. Layer n minus 1 provide service to layer n. This is a service here. Service here. Service provided through interface. So here is the service and or interface. So service means and layer N provide service to layer +1. What is the protocol? Here's service. What is the protocol? Protocol means a peer entity. Peer entity is here. In another machine, we have layer n-1, layer n, right? And layer +1 in another machine. So we have machine A, machine B want to exchange information. So what is the protocol? Protocol is here. This is a protocol. P, protocol n-1 or n+1. Here we also have protocol here. Protocol in layer N. So denoted by N. Protocol N. And then we have protocol n-1. So their service means layer N provided to layer n+1. Protocol means the rules between the peer entity at the same layer n+1, or the rules between the peer layer N. That is just the distinction between service and the protocols, right? So I hope all of you understand the service and protocols concepts, because they are very distinct concepts. So okay, the relationship between the service and the protocols. Probably we understand this concept from this figure, where layer k -1, layer k, then layer k +1. Okay, so much for today. Bye. So much for today. Bye. If you have any questions, you are welcome to send messages in the WeChat group. Okay, bye.